Alrighty, guys. Here is your notes for 7.4. Okay, so just a quick review. Reducing radicals. All right, a couple things you've got to keep in mind. First thing, figure out what kind of radical is it. Is it a square root? Is it a cube root? So what kind of root are we looking at? Okay, and then when you actually figure that out, you go ahead and break down by number and then by variable. So first things first, what tells us what kind of radical it is the index. Okay, so remember the index you can find it's sitting right here. That's the index. We will refer to it a lot of times during these notes, so definitely make sure you know what the index is. Okay, so first thing, I don't see an index on that first example, but remember that means to us that is a square root. Okay, so first thing, number, square root of 9, I can do that. It's easy, it's just 3. Okay, then I go ahead and look at my variables. Now with the variables, what you're doing is you're taking the exponents and dividing it by the index. Okay, so in this case my index is 2, so everything gets divided by 2. So 2 divided by 2 is just 1. Okay, 8 divided by 2 is 4. Okay, 19 divided by 2 is not an even number, so I have to go to the one below it, which is 18. So 18 divided by 2 is 9. Okay, then I go ahead and say, wait, there's a remainder of 1. Okay, so that's how I do that first one. Second one, it is a cubed root. Okay, I can tell by the index. So first thing, the cube root of 64 is 4. Okay, now instead of dividing by 2, I'm dividing every exponent by 3. So 9 divided by 3 is 3. Okay, 4 divided by 3, well, that's not very nice to us, but I know that 3 goes in there once. I know that I will have a remainder of 1. Okay, 14. 3 goes into 14 4 times, which would give me 12, right? And that's 2 away from 14, so I can have a c squared there. All right, so that's just a review of what we were doing beforehand. Shouldn't be anything too crazy there. Okay, when I'm doing these notes, I'm going to skip around a little bit because a lot of the examples are the same, and obviously this is a video, so there is no questions. So we're going to move on. All right, so radical form to exponential form. All right, so the key thing here is to remember that the index is going to be your denominator. Okay, whatever's on the inside is going to go together as a base and a numerator. So as I can see here, all right, let's come up with an example here. So if I had the square root of x, we'll keep it simple. All right, square root of x. The index is 2, so that would really be x to the 1 half. All right, so that's how that works. Okay, exponential from form to radical form. Okay, so if I started with something like this, x to the 5 over 3. Okay, what I'm going to do, numerator goes inside with my base, denominator is my index. So what does that look like? Okay, base goes in, numerator goes with base, denominator goes in the index. Okay, so that's how that works, that's how that looks. Okay, so it's just converting. All right, so that's what today is mostly about, is converting. So this first section, I know without even doing anything right away, I'm just converting to radicals, right? So every answer that I have here has a radical. Okay, now I just got to fill out the missing pieces. Well, I know all of my bases are going in. Okay, now I just got to fill out, is there an exponent, is there an index? So in this first one, remember, numerator goes with the base, denominator is your index. Okay, numerator goes with base, denominator, index. Okay, numerator goes with base, denominator, index. Denominator, index. Right? If it's a square root, I don't need to write a square there, but if you do, that's okay. All right, here I've got the square root of 36. We can do that. 6. All right, so that's really the only extra thing you'll be asked to do is actually, bring it down to its simplest form. Okay, going the opposite direction. Okay, all right, so I know all of my bases have to be there. Okay, now I just got to remember this. Okay, exponent goes as the numerator. denominator is the index. Exponent numerator, denominator is index. Okay? Exponent numerator, denominator is the index. Okay, should be, pretty straightforward here for you. I mean, there's really no way to make a conversion difficult. Okay, it should be pretty quick. Okay, all right. With numbers, let's do it with numbers really quick. Okay, to the 1/3. If you're not sure, go ahead and convert it. This is really asking you what is the cube root of 125. Well, that's just 5. Okay, here, this one is just asking you what's the square root of 64. Well, that should be easy. It's 8. Okay, next one here. In order to multiply, I need to make sure that their exponents are the same, or I can convert both of them. So let's just convert both of them really quick. Remember, to multiply roots, they have to be the same kind of root. They are. Okay, so that's the square root of 25, which is just 5. All right, down here, same deal. Okay, if the exponents are the same, you can go ahead and multiply them. This is asking about cube roots. 10 times 100 is 1,000. So the cube root of 1,000 is 10. All right, negative exponents. Remember, negative exponents means just shift where everything is at. Okay, so that's how you handle that. Okay, nothing, again, I don't think anything's too crazy here, but that's how you would handle that. Okay, all right, simplify, here we go. Again, 1/2 really means square root. So again, if you're not sure, convert it. If you are sure, you can go ahead and, write what you got to write. Okay, so I'm okay with either. It doesn't really matter to me. All right, so as I'm going through this, okay, the square root of 16 is 4. Okay, divide the exponents by 2. All right, nice and simple. Here, I've got the cube root. It's to the 1/3. So 64 x to the 6th, y to the 9th, and z to the 15th. Okay, go ahead. Cube root of 64 is also 4. 6 divided by 3 is 2. 3 and 5. Okay, so that's that. All right, I'm going to skip the next two. I will post a full filled out version for you guys as well. All right, so okay, when we solve radical equations, all right, there's not much new to it other than you have to ask yourself, are the radicals by themselves? Meaning there's nothing on the outside of the radical on the side that the radical is on. So this first example, I have the square root of 3x minus 2. Okay, so it is by itself. Everything is underneath that radical, so I can get rid of it. How do you get rid of that? You go ahead and you square. Come on, square both sides. Okay, so that side squared, just what's underneath comes out. 4 squared is 16. Now this is an algebra 1 problem, right? There's nothing crazy about this. Go ahead, you add your 2, divide by 3. Okay, nice and easy. Over here, this 7 is on the outside of the radical, so we need to get rid of it first. So instead of adding 7, I'm going to subtract it. Okay, so gives me this. Now radicals by itself, go ahead, square it. Okay, so 5x equals 25. All right, finally. All right, nice and simple. Okay, so there's really not a lot to this. There's not really new steps. It's all the same. Okay, so again, what you're asking yourself, is a radical by itself? So on the left side of the equation, is anything on the outside of that radical? No. So I go ahead and I can start by squaring everything. Okay, squaring the side with the radical just brings out what's underneath. Okay, opposite side, you do the square. Okay, go ahead, add your 8, divide by 6, and there you go. All right, over here, this minus 8's on the outside, got to do the opposite, so you add 8. Okay, go ahead, square both sides. All right, and then finally, divide by 10. Okay, so nice and simple. That's it, really. That's it for notes. So make sure you get that little note worksheet done, and then I will post the PDF work for later this week. So be ready for that. Okay.